Good morning, Jury. The topic for this research study is that how can we build a recommender system by using natural language processing techniques and audio feature analysis. These two tasks are performed separately. So we have used two data sets for this research study. The first data set includes the lyrics, so we'll be first examining how the NLP is performed. We have first downloaded all the necessary libraries for the model. Next, we have input all the files for all the artists which we will be examining the lyrics for. The second is that we have removed all the stop words and the lemmatization has been performed to split into single words which are understandable by the machine. The next step is in which we will be making a list of all the unique words that we have found in the lyrics, and then the cleaning of the data frame has been performed since there were some unwanted words in the title column and the lyrics column. So we have replaced them with understandable words, and then those words are dropped. And then again, the a word count has been performed. Then a statistics has been performed for the unique words, total words, and the total new words which we have. We have allocated them and we have printed the new data frame which is in front of you. This is the new data frame that we have got with the new column as words which are machine understandable. And then we have actually calculated the length of the lyrics which was before and which was after performing these things. The next step is which very important, in which we have actually calculated the lexical richness for all the artists, and we have given the lexical score for each artist. Then a little visualization is done to for a better understanding of total words versus unique words, that how many total words were there post and after finding the unique words, how many unique words did we get? And the same kind of visualization has been done for the lexical richness of all artists. This is the graph that we got performing the lexical richness. After that, we have actually grouped the artists according to the year and how many albums did they release in each year. This is the visual representation of the same, the number of titles of all artists from 2001 to 2021. But this is a combined result. Now we have done the same thing for individual artists. Then in each year, how many titles have these artists released? So we have got a graph, something which looks like this here. The next very important step is that we have calculated the word cloud here to perform the next step, which is our sentiment analysis, which is the most important part of this phase of the research. We have actually used three sentiments for this research: the negative, positive, and neutral sentiments, which we will be calculating for each song, and post that after doing an average for all these three, we have been getting a dominant score, which will be used for further analysis. So this is what our data frame looks like. After that, we have for each song, we have the negative sentiment, the neutral sentiment, and the positive sentiment. After doing an average, we will get the dominant score. So for example, here the dominant score is positive, as we can clearly see that the positive sentiment is dominating, and we have got a dominant score over here. Now, we have plotted a swarm plot against the dominant score and the dominant sentiment, so that we have a better understanding in terms of visualization for each artist. This has been performed. Now we have actually grouped the artist according to their dominant score over here, and this is the dominant score that we are getting. And then we have done a positive valence versus negative valence, and this is the graph that we are getting. Now moving on to the next part, which is actually very important of doing the cosine similarity, so that we can actually come up with some recommendations for the song. So these are the artists, and this is actually the first song in the data set. So we have taken the first song into consideration for our recommendations. So we have given the cosine similarity score, the similarity score using TF, IDF vector, and these are the similarity scores. So this is the list of the similarity score over here, and we have given the similarity score. Those This is the similarity score for each song. And now, just for the checking, we have first put the similarity score as greater than 1. So the recommendation is the song itself, which is taken as the reference. Now we have actually used 0.25. The similarity score should be greater than 0.25, and these are the recommendations that our machine has given to us after doing the similarity analysis. And the recommendation that we got is this. Now we will be moving on to the next phase of this research study, in which we will be actually extracting the audio features of the audio. So in this data set, we have used audios which are 30 seconds long for 10 genres, and each genre has 100 files. We have imported all the required Python libraries, and especially the Librosa library, which is actually very important for this model. Now, moving on, we have given the path for all the genres. The genres used as blues, classical, country, disco, hip hop, jazz, metal, pop, reggae, and rock. Now, we have given the first path for the first genre, which has been taken as reggae, and we have actually calculated the sample rate for the same, in which we got the length of the audio as 30 seconds approximately. Then we have trimmed the leading and trailing silence, which means that there is some silence in the starting, ending, and maybe sometimes in the middle of the song, which is unnecessary. So we have removed those sounds. Then a 2D representation of the same has been done using Librosa library and sample rate. After that, we have done that for each genre. Post that, Fourier transform has been performed, and in this, since the audios were discrete in nature, that's why we have performed fast Fourier transform and short-term Fourier transform using the hop length and the window size over here. After performing the Fourier transform, we have actually changed the time domain of the audio signals to frequency domain, and doing that, we have actually lost the time track for the audio, so we don't know the ending and the starting point of the song. That's why we have here now performed spectrogram and Mel spectrogram, which will actually helped us finding the starting point and the ending point of the audios that we are using. Also, they have changed the frequency domain of the signals to the logarithmic one. And Mel spectrogram has actually helped us by including the Mel scale on the y-axis. And here you can see the clear representation of the Mel spectrogram. The darker areas means that the frequency are higher over here. Then we have done the total zero crossings for the sine waves, and we have actually found out the harmonics also. These are the harmonics. Now when we come to feature extraction, we have actually included spectral centroid, spectral roll off. So this is the spectral centroid, the centroid of the spectrum. Then this is the spectral roll off, which we have found out. This is the MFCCs, and we have done the mean and variance for the MFCCs. We have also found out the chroma frequencies over here. These actually constitutes to the timbre features of any audio. A correlation heat map has been plotted, and as you can see, MFCC2 mean is highly correlated with the spectral bandwidth mean. The box plot has been plotted for finding the outliers. Then the visualization is done, and also here we have done the PCA for dimensionality reduction. Only two dimensions have been taken care, and then we have normalized the data using min-max scalar. Post that, we have now actually applied machine learning programs, machine learning models. We have used 7 machine learning models, and to do that, we have actually augmented our data set, because we needed a larger data set to train the models. We have broken down the 30 seconds audio into 3 seconds each, and we have input that thing, that file. We have split our data into train and test, so the test size will be 30%, and we have now assessed the performance. So the best performing is random forest. After that, we have also used TensorFlow, and we have now um, found out we have now also used XGB classifier for classification of our model. Before that, we have done another correlation for the new uh, 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 audio features that we have extracted. This has been done. Now XGB will be used for classification. The accuracy which comes out to be for accuracy for XGB is 89%, which is also promising. A confusion matrix to find out the correlation between the machine learning models is plotted. Then now we have actually used convolution neural networks, because since we have converted the data set to an image data set, convolution neural network is the best for image data set and classification and prediction. So ReLU activation function here is used with Adam optimization, and we have run 1500 epochs, and the accuracy has come out to be 93% with the test loss as 72%. So we will be going forward with CNN as our classification and prediction model. Thank you so much.